Lesson 6, parallel and perpendicular lines. So we're going to review the idea of some transformations. If I take a point A that's at 2 and 5, and I've translated 3 units to the right and 2 units up, where will it be? 5 and 7. Okay. I'm not going to worry about the rotations for now. I'm going to actually skip to investigating parallel line segments. On the grid, we're going to take line segment AB and we're going to do the following transformations. If I take this line segment and I do a translation of 4 units to the right and 1 unit down, I'm going to get line segment CD. So I go 1, 2, 3, 4 to the right and 1 down. The same thing with B. 1, 2, 3, 4 and 1 down. Connect the 2 points. And there's my line segment CD. So I'm going to give you a moment. I want you to do the same thing to find line segment EF and GH.
Is it often
Okay, so the next thing we're going to do is we're going to write down what our coordinates are. Actually, no, we don't need to write down our coordinates. Okay. We are going to calculate the slope of each of these line segments. So the slope of AB. First of all, what can you tell me about all 4 of these slopes? Are you sure? Okay, what else can you tell me before you even do the numbers? They're all going to be negative because they all fall left to right. Okay, so now if I look at the slope of each of these, rise over run. I went down 3 and over 6. Down 3 and over 6 is the slope of -1/2. So then the slope of CD, down 3 over 6, the same thing. EF, down 3 over 6. So I get that reducing to 1/2. And the slope of GH, down 3 over 6. So these are all parallel lines. So from here we can make a conjecture, which is basically, it's kind of a statement based on the evidence that we've seen. So based on the evidence that you've seen, what can you tell me about slopes and parallel lines?
They're the same.
Yes. Parallel line segments have equal slopes. Okay. What can you tell me about perpendicular lines? How do I know if 2 lines are perpendicular?
They form a 90-degree angle.
They form a 90-degree angle. So perpendicular lines intersect at a 90-degree angle. They have a T intersection. Okay? So on the grid, we're going to plot the point 5 and 2. That's point A. And we're going to join this point with the origin. Now, if I rotate this line 90 degrees clockwise, so 90 degrees clockwise about the origin, which means that becomes my anchor point. I'm rotating this. Where would point A go to? So this was at 5 and 2. So where would it go to?
5 and negative.
Down here? No. We interchange,
It'd go negative.
not negative 2 and 5,
Negative
or
5 and negative
2 and negative 5. Apparently it's not. There we go. It would go to this point. So then when I draw this line, if I rotate it at 90 degrees, this should make a 90-degree angle, correct? And does it look like it makes a 90-degree angle? Yes, it does. Okay? So let's call this point B, which was 2 and negative 5. So we're going to do the slope of AO. That's this line segment right here. So that would be 2 minus 0 over 5 minus 0. So what would the slope be? 2 over 5. Which we can also get from counting up 2 over 5. Okay? This is a positive slope. This would have to be a negative slope. So if we use our slope formula to find that slope, I get negative 5 minus 0 and 2 minus 0. Negative 5 over 2. Which again, if I count, down 5 over 2. Okay, so we're going to take another point. Point B, which is at negative 6 and 1. So, call point B in green. If I rotate this 90 degrees clockwise, this point, which was negative 6 and 1, will become what? So it's going to go into this quadrant here, 1 and 6. So it becomes this point. And if I look at the angle between those two lines, does it appear to be a 90-degree angle? Yes. Okay, so let's find the slope. So if I find the slope of this line, it went down 1 and to the right, how many? 6. So down 1 would be a negative 1 over 6. So I get negative 1/6. If I look at the slope of the other line, we'll call it CO. So this is my point C. What's my rise? 6 up, and my run is 1 to the right. Okay. We're going to do one more thing with these slopes. So I take these two numbers. Multiply them together. What do you get? 2 times negative 5? Negative 10. 5 times 2? Negative 10 divided by 10?
You're multiplying by the inverse. So.
Not inverse. We don't call it an inverse.
Reciprocal.
Reciprocal. Good. So what you're saying is, what is the pattern between the two numbers? It's a reciprocal, but what else did I do? I didn't just reciprocate the 2/5. I gave it a negative. I gave it the opposite sign. So if I flip negative 1 over 6, I get 6 over 1, and then the opposite sign. So if this was negative, this would be positive. This is positive, this would be negative. So what conjecture can we draw about perpendicular lines? What can you tell me, first of all, what can you tell me about the product of their slopes? Product meaning to do what? Multiply them. So what can you tell me about when I multiply their slopes together?
You get -1.
Okay, so the product of their slopes is -1. And then what can I say about the pattern? So Jonathan, you would use the word reciprocals. So they are, I'm going to put a blank in front of reciprocals. Because it's not just that they're the reciprocal of each other. If one slope is 2/7, what would the other slope have to be? -7/2. If one slope is -4/5, the other slope would have to be 5/4. What am I multiplying by to get that negative? Just by a negative. So we can say that they are negative reciprocals of each other. So I take the reciprocal and I multiply it by a negative. When I multiply this by a negative, I get a positive. Multiply this by a negative, and there's my negative. The bottom of the page looks at kind of a proof of why this works. So what we have is we have 2 points on a graph. The 2 points are such that I took this line and I rotated it 90 degrees. This is a 90-degree angle. I've set it to be a 90-degree angle. If I find the slope from the origin to point P, it would be b minus 0 divided by a minus 0, which I can write as b over a. If I look at this point, the relationship between the coordinates, what we saw in the previous example, is they get interchanged. So the b becomes the x-coordinate, the a becomes the y-coordinate, and it's a negative because I'm in the 4th quadrant. So now when I calculate the slope from the origin to point Q, I get -a minus 0 and b minus 0, which gives me -a over b. And in the last step, when I go to multiply these together, I get -a times b over a times b. A's cancel, b's cancel. I'm left with a -1. Two lines are parallel if their slopes are equal. Two lines are perpendicular if the product of the slopes is -1, or if the slope is the negative reciprocal of the other. Okay? Provided that neither slope would be equal to 0. Because the minute I have to take a perpendicular line to that, well, first of all, my 0 slopes are horizontal lines. So it would have to be a vertical line, in which case it could be anywhere along that line. There's multiple points that I could put it through. If I have a line segment AC that has a slope of 3/4, what would be the slope of line segment GH if it is also parallel to AC? So I have two lines. This is AC, and I have GH, and it has to be parallel. So what has to be the slope of GH? Say that louder. Which is? 3/4. Okay. If I have line segment BF and it's perpendicular, what would be the slope of BF? Say it louder. -4/3. It has to be perpendicular. So perpendicular means I take the reciprocal and the negative. Determine if the following slopes are parallel, perpendicular, or neither. What do you notice about 3/12?
It's gonna be new.
And if I reduce it, what do I get? So they're parallel because they are the same. Okay, what about M1 and M2 in B?
It's neither parallel or perpendicular. It's negative.
What should I do with this?
You can reduce it to 7, but it's not negative.
It's not negative. So when I go to multiply these together,
You just get 1.
I get 1.
Not negative.
So they're not perpendicular, and it's not parallel. It's neither. They're just two intersecting lines. Okay? So your final piece to work on is questions 3 to 6. So we're going to pick up where we left off in the last class with parallel and perpendicular lines. So just a quick review. Parallel lines have equal slopes. This is at the top of page 539. So if two lines have the same slope, they're parallel. If two lines are parallel, they will then have the same slope. Two lines are perpendicular, meaning that they intersect at a 90-degree angle. If the product of the slopes is -1, or if the product of the slopes is -1, then they have to be perpendicular lines. And the other way, or the other scenario with perpendicular lines, is the slope is the negative reciprocal of the original. So if the original slope is 7/2, the reciprocal would be -2/7. Or if the original slope is -1/3, the new slope would be a +3/1, or just 3. So we'll continue on with the class examples with class example number 4. P is a point and Q is a point on a line segment. Find the slope of the line segment that would be parallel to PQ. So what I need to do is I need to find what the slope of PQ would be. So the slope is the difference in the y-coordinates. So 7 minus a -2 divided by the difference in the x-coordinates, which would be 4 minus 6. I need to be consistent, so because I went 7 minus -2, I'm going to go 4 minus 6. So 7 minus -2 would become 9. 2 minus 6, or 4 minus 6 would be -2. So the parallel slope would be -9/2. If the line segment is perpendicular to PQ, the perpendicular slope would be the reciprocal of this, which would be a 2/9, and would have the opposite sign. So instead of being negative, it would now be a positive 2/9. So if we look at the next page, triangle LMN has the following coordinates. Use slopes to show that the triangle is right angled at point L. So if we did a very quick sketch of what this would look like, if I graphed L being at -4 and 2, M is at -2 and 7, and N is at 1 and 0. So M and N. So what I want to do is I want to prove it's right angled at L. So what I want to do is I want to prove that the slopes LM and LN are perpendicular. Because in a right triangle, those have to meet at a 90-degree angle. So if I find the slope of LM, so that's the difference in the y-coordinates and over the difference in the x-coordinates. So I can go 7 minus 2 over -2 minus -4. So 7 minus 2 is 5. -2 minus -4, this would become a positive, and I would get a +2. So that means that the slope of LN would have to be the reciprocal, which would be 2/5, and the opposite sign, so it would have to be a negative 2/5. So if now I use my points L and N to calculate the slope of that line segment, the difference in the y-coordinates, so 2 minus 0, over the difference in the x-coordinates, negative 4 minus 1. So 2 minus 0 is 2, negative 4 minus 1 is negative 5. Bring the negative out to the front. Are these two perpendicular slopes? Yes, they are. And the way that I can prove it is if I multiply them together, I get negative 10 over 10, which gives me negative 1. So yes, triangle LMN is a right triangle. Okay? So the last question, two lines have slopes of negative 3/4 and k over 5 respectively. Find the value of k if the two lines are parallel and if the two lines are perpendicular. So if the two lines are parallel, that means that their slopes has to be equal. So negative 3/4 has to be equal to k over 5. So I can cross multiply. Negative 3 times 5 is negative 14. 4 times k is k. Divide both sides by 4, and I would get negative negative 15/4. Yes, if we can leave it as a fraction. Okay? For part B, if the two lines are perpendicular, it means if I take negative 3/4 and I multiply it by k over 5, I will get negative 1. So I get negative 3k over 20 equals negative 1. I'm going to multiply by the 20 to get rid of the dividing by 20. So negative 3k equals negative 20. Divide both sides by by negative 3, and I would get 20/3. So to add to your questions from the previous part, questions 7, C and D, 9, 10, A and D, 11, A and D, 13A, 15, and 16.